Okay, so yesterday we did a little quiz, and then I gave you guys time to look at questions 7 and 8 from the handout. I guess before we get going, does anyone have any questions about number 7 or 8? Would you like to see me do any of them? 7B?
Yeah.
Sure. Can you just quickly tell me which one 7B is? Where am I looking? Here, insert blank. That's what I want. Alright, so 7B is sine A equals 7 over 25. And then it wants us to find what again?
Sine 2A.
So it wants us to find sine 2A and cos 2A and tan 2A?
Yeah.
Alright, perfect. Okay, so again, what we need to do is figure out first what cosine of A is going to be, because once we know cosine and sine, what we can do with these three trig ratios is break them up into their identities, right? So once we know what cosine and sine is, then it'll just be a matter of plugging them in and solving. So to find cosine A, it can be helpful to think about the right angle triangle that contains the side lengths we're talking about, right? So if this is my angle A here, then the 7 is our opposite, and the 25 is our adjacent. And I believe this is another one of those Pythagorean triplets. 3, 4, 5 is the most common one that we see. I believe this one's 24, 7, 25, if I'm not mistaken. Now, if you're not sure, what you can do is you can solve for that side length by finding the square root of 25 squared minus 7 squared, right? So we get the square root of 625 minus 49.
Mr. McMillan, would you call it to the office, please? Ms. McMillan, would you call it to the office?
Which is the square root of 576. And then if you did square root of 576, what you find is that the missing side length is 24. So now that we know that the missing side length is 24, now we can say that the cosine of A, which is adjacent over hypotenuse, is going to be 24 over 25. So far, so good?
Yeah.
Alright, so now it's just a matter of finding these things by using the identities, right? Sine 2A is equal to 2 sine A cos A. And now that I know the values of sine A and cos A, let's plug them into my equation. So 2, and then sine A is 7 over 25. Cos A is 24 over 25. So when I do that multiplication, I get 625 on the bottom, and then what do I get on the top? 336. And that is our answer. Can't be simplified, and you can see kind of from this that it can't be simplified, right? This is 5 times 5, this is 5 times 5, there's no 5's in the top, so there's nothing you can do to simplify this thing. This is as simplified as it's going to get. Same thing with the cosine. So if we do the cosine of 2A, we just have to pick one of our three identities, right? They should all give us the same answer. So if we use the cos squared A minus sine squared A, right? And then plug that in. So we have cos squared is 24 over 25 minus sine squared, squared, minus 7 over 25 squared. So that was 576 over 625 minus 49 over 625. And then 576 minus 49 is 527 over 625. And again, we know 625 is 5 times 5 times 5 times 5, and since there's no 5's in 527, this is as simplified as it's going to be. Right, so here's my sine 2A up here. Right, here's my tan 2A down, or sorry, my cos 2A down there. And then to find tan 2A, right, what we can do, there's two ways of doing this. There's recognizing that tan is sine over cos. So we could do sine 2a over cos 2a and then simplify it. Or recognizing that sine is opposite, sorry, it should be O, opposite over adjacent. Tangent is cosine is adjacent over hypotenuse. Woo, and tan is opposite over adjacent. So now if I know my opposite is 336, I know my adjacent is 527, so it's 336 over 527. Which I believe is as simplified as that's going to get. So then that would be our answer. 336 over 527. Is that okay? Any questions?
No.
Cool. Any other questions from number 8?
Yeah, 8B.
8B. Yeah, that was one that people regularly, I don't want to say struggled with, but had a hard time with. I might have it here. Yeah, maybe just read it to me. I don't have it right in front of me.
Cos 2x.
Cos 2x, cos.
Oh yeah. Cos 2x, cos x. Yeah, I got it. Plus sine 2x, sine x, right?
Yeah.
Okay.
Cos 2x has multiple ways to change it, so we start off with cosine 2x first.
Okay, so and a lot of the times what students want to do is they see cos 2x, sine 2x, and they right away are like, okay, there's my double angle identity, let's expand it. But I would argue there's a much easier way of doing this question. Look at it backwards. Which identity is this already?
Cos 2.
It's already cos
2a minus x.
2x minus x, right? Do you guys see that? That's your sum and difference identity.
Why would it be 2x minus?
Oh yeah.
Because if you look, our identity is cos of a minus b is cos a cos b plus sine a sine b.
Yeah, but where did you get like the 2x and the x from?
A
Oh.
B. A
Never
b.
mind.
Right? So then what is this?
Cos x.
Cos x. Now, is that the only way to do it? Obviously not, right? The fact that we have our double angle identities here means that we could expand them using our double angle identities, and then what we would find is that you end up factoring out a cosine x, and then the thing that you're left with turns into 1. And then you get cosine x times 1, and you end up with the same answer either way. But being comfortable with your identities will help you kind of skip doing all that work, applying your double angle identity twice, and recognizing it as maybe one of my other identities. Okay? Now, I mean, I could do it by expanding if you guys would like, but I just think that's a bit of overkill in terms of like the work that needs to get done. Is that okay? And I guess the other thing too is like, what if I gave you the same question, but instead it was cos 3x cos 2x plus sine 3x sine 2x, something like that, right? Again, what ends up happening here is if you try to expand this thing, it'd be a mess, right? It'd be this huge, monstrous thing that eventually would simplify to give you cos x, right? So if you can recognize it as this identity right away and just do 3x minus 2x, oh great, there's my cos x. Is that okay? All right. So, any other questions from 7 or 8? No? All right, so last thing that we're going to talk about before we're kind of done with content is proofs, right? We're coming back to this idea of proving something by using these identities we've been working with, right? So, let's take a look at a couple of examples, and then I'll get you guys to try some on your own, okay? So, how do I prove this thing? We've been working with proofs for a little while now. So how am I going to prove this thing right here?
Start with the left-hand side.
Yeah, right, left-hand side, right-hand side. We're going to take a look at these things that we've been working with and try to turn one side into the other. Now, one strategy that we're going to want to use is the fact that we have a double angle identity here. Means we probably are going to want to start with this side. Not always, not necessarily, but more often than not, this is probably the side we're going to want to start with. Okay, so how are we going to start with this side? Well, let's do that double angle identity, right? So my left-hand side is 1 plus tan squared x cos 2x. Okay, so what now? We have to kind of figure out which identity we want to use, right?
Change tan.
You want to change tan into what?
Change that
Like change tan like this? Is
Sine 2x.
that what you mean?
Maybe you want to leave it because tan is in
A lot of ideas, no one's quite
I
sure.
would explain
Cosine 2x,
cos
if we
2x
use the one with the negative 1, then we can end up with 2 terms on the left instead of 3 or 4. Because it's
So if we left this as tan squared x for a second, and we change this one into 2 cos squared x minus 1, is that what you're saying?
yeah. Then there's plus 1 and negative 1, so it'll be much simpler than the other identities.
Okay, so if we did this, now we'd have to expand, right?
Yeah.
So let's do that. So what do we get? We get 2 cos squared x minus 1 plus 2 cos squared x tan squared x minus tan squared x. Is that okay? Everyone with me so far? So, the nice thing is, what am I trying to get from this identity? I'm trying to get a 1 and a negative tan squared. What have I just found here? I've got my negative tan squared, right? So, awesome. So that's kind of the first step of, okay, there's my negative tan squared. Now, how am I going to get the rest of this identity? Well,
Factor 2 cosine, 2 cos squared x.
I wouldn't factor anything just yet. What I would do is apply my,
Change tan.
yeah, let's change tangent, right? Let's take a look at what tangent is in terms of sines and cosines, and let's see if things start canceling, right? So we get my 2 cos squared x, and then sine squared over cos squared, right? And what do we notice when we do that? They cancel, right? Our cos squareds are going to cancel. Now I'm going to rearrange this for a second. I'm going to put this negative 1 after that. So we get 2 cos squared x plus 2 sine squared x minus 1 minus tan squared x. Okay, now what?
2 cosine squared x plus 2 sine squared x equals 2.
Right, exactly. So if we take a look at just these first two terms here and we did some partial factoring, right, this thing is 2 times cos squared x plus sine squared x. And what is cos squared x plus sine squared x?
1.
Right, so that means this thing is 2 times 1. And 2 times 1? 2. 2 minus 1 is?
1.
So what are we left with? 1 minus tan squared x, which is the right-hand side. QED.
I have a question.
What's up?
So, can you go up?
Yep.
How did you get, like, from
Sorry.
how did you get, like, from the first line, like, cos 2x to 2 cos squared x minus 1?
So this is one of our identities.
Oh, okay.
Right, cos 2x has three options, right? It's
Oh,
cos
right.
squared x minus sine squared x. It could also be 1 minus 2 sine squared x, or the third one is 2 cos squared x minus 1, right? So we had to make the decision of which identity to use.
Yeah.
So CoA suggested the one with the negative 1, because this had a positive 1, so maybe we might see some canceling going on if we did that, right? And that's just it, right? Knowing which identity to choose, sometimes it'll be a little bit more obvious than others, but no matter which one you choose, you should get the same answer. And what I mean by that is if we were to use the cos squared minus sine squared here, again, what we would have found is that a cos squared times a tan squared would have canceled out it would have left us with a positive sine squared, and then our sine squared times the negative sine squared times 1 would have given us a negative sine squared, and our positive sine squareds and our negative sine squareds would have ended up canceling then, right? So no matter which identity you chose, what would have happened is things would have added and subtracted to cancel out and still leave us with this 1 minus tan squared x. It's just a matter of trying to see which one might be the easiest, or at least having a theory about which one will be the easiest, and then attempting it, and then seeing if you can't get to your answer from there. Okay? Any other questions? A little bit weird, a little confusing. So maybe if we take a look at another one. So prove that cosine to the fourth x minus sine to the fourth x is equal to cos 2x. So where do you guys think we should start here? I'd probably start with the left-hand side. I would imagine some people's first instinct would be to start with the right-hand side, because that's where my double angle is, right? Now, sometimes it can be easier to try to get to the double angle. Sometimes it can be easier starting with the double angle trying to get to the identity. For this question, I would probably start with the left-hand side, because which of the three identities do you think we're probably going to try to make here?
First one.
The first one. We're probably going to try to find the cos squared x minus sine squared x somewhere, right? Because we already have cosines to some power, sines to some power, and a minus sign going on here. So it really would make sense that if I can get it to this point here, the next step is just going to set it equal to cos 2x, and then I'm done. So let's start with the left-hand side and try to go from there. So cosine for x minus sine to the fourth x. All right, so what are we going to do?
Do you have to repeat? You have to rewrite everything?
You should. If you're going to start with the left-hand side, I want to see, well, the left-hand side is this. I mean, it's just good habit. It's not like I can't follow your work if you didn't, but it's just a, I don't know. It's a word I'm looking for. I don't know, good practice, I guess. So, if we started here, what should we do? We should factor it, right? This is a difference of squares, where the square root of cos to the fourth is cosine squared. And the square root of sine to the fourth is sine squared. Now what?
Cos squared x plus sine squared x equals 1.
Right, this thing right here is 1, so 1 times cos squared x minus sine squared x. Now, what is cos squared x minus sine squared x? Right, that was that identity that we decided, okay, it's probably going to end up being this one, so it is cos 2x, which is the right-hand side. QED. Is that okay? So that's it. Like this, that's basically the content for this unit, right? We've seen sum and difference identities, double angle identities. We've used them kind of both forwards and backwards. We've applied them to those basic trig ratios that we've talked about in last year, right? By using the opposite adjacent hypotenuse to try to kind of find what happens when we make 2a. And then the last thing we're talking about are these proofs. How do we take these things and prove them? So there's a couple of these exam style questions up here for you guys to try if you'd like. The other option is your handout, number 9. right? That's what we're going to be doing today. Getting some practice in. I'll have a bit more practice tomorrow, but after tomorrow, we're done with the double angle identities. So I don't like to test on Mondays, so we're going to test on Tuesday. Monday, we're going to just briefly touch on not necessarily the next unit, but one thing I would like to get to before we end this unit. It's not going to be on your test, but it is something that I want to talk about before we finish this unit off, okay? Sound good? Cool.